Okay, we'll continue on what we have covered last week, which is future value. Okay, and some of the formulas that we have covered for the future value, present values, present value entity, and future value entities. Okay, we know that, for example, if you are looking for a credit card, actually the credit card company will emphasize that their credit card has a cost of 18%, right, annually. But actually you are not paying 18%, you pay more than 18%. Okay, the effective annual rate is actually can be calculated using the formula, which is 1 plus k divided by m power m, then you minus by 1. Okay, so in this case, right, the effective annual rate that you have to pay to the credit card company is actually 19.56% per annum. Okay, it is not 18% as being advertised in the newspapers, or by the salesman, say that the credit card only carries 18% interest rate. But actually you are paying almost 20% per annum. It is quite high. Okay, it is also the same for if you want to go to you have to get any loans from the banks. Okay, you have to actually calculate the effective annual rate instead of using the annual rate. Okay, the nominal on your annual rate. Okay, because you pay actually more than what it is being presented, which is the nominal rate. Okay. Now, for the first topic, okay, we will cover today is the present value. Okay, the present value is actually the current dollar. Okay, the current dollar value of a future amount of money. This is because a dollar today will not have the same value as a dollar tomorrow. Okay, it means that a dollar tomorrow have more value than a dollar today. Okay, so that is what we have because of the fiat money. You know what's fiat? Fiat money is paper money. Paper money, the value keep on decreasing in value. Okay, so that's why sometimes you say that you can buy with a 10 cent of your money, can buy lesser of sweets compared to what you can buy 10 years ago, right? Because the value of the money actually decreasing. Okay, compared to other commodities such as gold, right? So this is because of the time value of money. Okay, it means that a dollar today it does not have the same value as a dollar tomorrow. Okay, it is based on the idea that a dollar today is worth more than a dollar tomorrow. Okay, so it means that a dollar tomorrow have depreciated in value. Okay, $1 today is worth more than a dollar tomorrow. The word. You can buy a lot of things today compared with the same dollar tomorrow, right? So it is because of inflation rate, time value of money, and all that. Okay, so this is the basic concept of time value of money, right? So it is the amount today that must be invested at a given rate to reach a future amount. Okay, so when we look at our present value, we have to link it with the interest rate so that we can get a future amount of money, right? Calculating the present value is also known as discounting. Okay, before we have already learned about the future value, which is for we compound the interest rate. In this case, we discount the interest rate. It is the vice versa of the compounding factor. Okay, so it is the vice versa. Okay, the discount rate is often also referred to as the opportunity cost, the discount rate, the required return, and or the cost of capital. This is the other name, okay, of discount rate of for the it is also called opportunity cost, okay, discount rate, required return, and also cost of capital. Okay, if you look at the question, sometimes it shows it is used the other name. Okay, now let's see one example of the present value. We'll use the formula and also we'll use the financial table. Okay? Okay, how much you deposit today in order to have 2,000 in 5 years if you can earn 6% interest on your deposit. Okay? Now let's see how much is the amount that you have to invest today. Okay? You have to put in the bank in order for you to earn 2,000, okay, in 5 years time. Okay? And you know that you go to the bank, sometimes it mentioned to you that the interest rate is 6%. Okay, now we assume that the 6% interest rate is constant. Okay, it's constant. You are going to the bank, okay, I want to put my money in a fixed deposit, right? 6%. Right? So how much do you have to deposit in the bank for you to get this 2,000 ringgit? Okay, we'll use the formula. What is the formula? Present value, we are calculating present value, right? Formula is present value equal to future value. Then you multiply with 1 divided by the present value interest factor. Okay, 1 plus k power of n is the present value interest factor. Right? Okay, 1 divided by present value interest factor. This is the formula. Okay, this is the formula. 1 divided by present value interest factor. Okay. Okay, if you use the formula, okay, you will get 2,000 multiplied with 1 divided by 1.06 power of 5. Okay, or if you use the table, okay, you look at the present value interest factor. Interest is 6% and n is 5. You get your present value interest factor. Okay, then you will get 1,494.52. Okay, this is the amount that you should invest, that you should have today for you to get 2,000 in 5 years time. Right? This is the amount that you will invest. Okay, you don't have to invest 2,000 to get 2,000 in 5 years. You should invest 1,494 because this is actually the present value of the same 2,000 in 5 years time. It means that the 2,000 in 5 years time has the same value as 1,494 today. Okay? Right? It has the same value. Okay. Right? Do you understand? Okay. Now using Excel. Okay? Using Excel, I'll show you how to use Excel, right? We go to Program, then click Microsoft Excel. Okay, now let's see this. Our future value is 2,000. Okay. Okay, our future value is 2,000. Then our interest rate, okay, is 6%, right? Okay, and then n is equal to 5 years, right? Okay, payment, okay, is 0. Okay, payment is for annuity, right? So it is not annuity, so is just put 0. So if you want to find the present value, okay, you click on the paste function here. This is paste function. Click here, right? Click there. Then you have to choose function category, which is financial. Then choose present value, which is PB. Okay, then a box will come out. Okay, this box will come out. Right, this box will come out. So what you have to do is you have to click on this box here, on the cell here, with the cell that you have already highlighted here. Okay, for example, rate is 6%, so you just click 6%. Okay, and per is 5, right? Just click 5. Payment is 0 because this is not annuity. Okay, future value is, this is the amount that you want to have in 5 years time, which is 2000. Okay, automatically you get the result down here, 1494.52, right? Okay, this is the result. Okay, type, this one we will use it when we want to find for ordinary annuity or the annuity due. Okay, so we just ignore this, right? So we just click OK, then we'll get the result. Just ignore the negative sign. Okay, ignore the negative sign. Okay, because this is actually stating that whether it's a cash out or cash in. Okay? Especially when we are using this for NPV, net present value. Okay, so when you are using the negative sign, it shows that you are taking from your pocket, which is cash outflow. Okay, that is your first investment. Then after that, you will receive a series of cash flow, right? So that cash flow will be positive. Okay, that is the differentiation between negative and positive. Okay, but for present and future value, you just ignore the negative figure. Okay, so 1494. This is very easy. Okay, very easy. And if you look, you can always play with this figure. Now let's say if you increase the interest rate to 10%, what happened to the present value? What do you think? You increase the interest rate to 10%. What do you think happened to the present value? It will decrease, right? You will have a lower value. Okay, 1, 2, 4, 1. You increase it some more, or about 15%, you will have a lower value, lower present value. Okay, and if you increase it to 20%, you will have a lower value. Okay, so the higher the interest rate, the lower the present value. So the effect is vice versa with future value. If future value, the higher the interest rate, the higher the future value. But for present value, the higher the interest rate, the lower the present value. Okay? So vice versa. Okay, now let's see if I change this one back to 6%, but now instead of the interest rate increasing, I will increase the end period. Okay, from 5 years, this is not my computer, my computer does not have sound. Okay, sorry. Okay, instead of 5, increase it to 10. What happened, do you think? What happened? What happened to your present value? It will increase or decrease? In or D? Decrease, okay? It will decrease, okay? Right? So, if you increase to 15 years, it will also decrease. 20 years is also decrease. So, the higher the interest rate, the lower the present value. The longer the term, the lower the present value. That is the basic concept of the time value of money. Okay, now we'll go back to our slide. Okay, using Excel we get 1495, which I've showed you before, right? Okay, this is how you are going to use that. Okay, this is the graphic view of the present value. Okay, now you see that if the interest rate is 0, the value of this $1 will be constant. It will be the same. Okay, it will be the same. Okay, if the interest rate increase from 5 to 10 to 15 to 20, the present value will decrease. Okay, the present value will decrease. Okay, and also if the period is increased from 5 to 10 to 15 to 20, okay, the present value also will decrease. So this actually, the present value has a vice versa effect from the future value. Okay. Now, continue on to the next slide. Okay, we finished with present value. Now we will continue on to annuities. Okay, this annuities is actually an important topic for you because this is actually being used in the insurance companies. Okay, normally it's being used by the insurance companies. Okay. Now, annuities are actually equally spaced cash flow of equal size. Okay, the basic concept of annuity is that it must have equal cash flow. Okay, equal cash flow in terms of size. Okay, it has the same. For example, for year one, if the cash flow is 500, then next year it will have the same cash flow, which is 500. Okay, the third year will have the same cash flow, which is also 500. So it has a same or equal cash flow, right? Now, it can be either inflows or outflows. It can be either we deposit or we receive. Okay, it can be either way. Okay, now also it can be ordinary annuity. Okay, which has cash flow that occur at the end of each period. Okay, we compound it at the end of each period. And also we can be annuity due, which is occur at the beginning of each period. This is what we call it. We compound it at the beginning of each period. So this is the difference. There are differences between ordinary annuity and also annuity due because the figure will be different. Okay, the figure will be different because the difference in the timing. Okay, you see that when we deal with the time value of money, when the time is different, okay, the timing is different, the value will also be different. Okay, because ordinary annuity you compound it at the end of the year, whereas annuity due you compound it at the beginning of each period. So it has different value. So an annuity due will always be greater than ordinary annuity. Okay. Otherwise, equivalent ordinary annuity because interest will compound for an additional period. So because it is the interest is being compound for additional period compared to the ordinary annuity. Okay, this is one example of the ordinary and annuity due. Okay, this is ordinary. This is annuity due. Okay. Now you see that the total cash flow is equal, right? 5,000. Okay, it is 5,000. It's the same. But the timing of the compounding is different. One is at the end, one is at the beginning. Okay? Right? So that's why you see that actually this timing, okay, would actually affect the value of the annuity itself. Okay, the timing itself will affect the values. Okay, so now if you look at this example, how much? Okay, this is ordinary annuity. How much will your deposits grow to if you deposit 100 at the end of each year? Okay, if we say that at the end of each year it is ordinary annuity. Okay, at 5% interest for 3 years. Okay, so now what you have to do is you have to use the table, right? Or you have to use the formula, either way. Or maybe you can use the Excel or calculator, right? You have 100 is your annuity, okay, or payment. And then 5% is interest, okay, and is 3. Okay, you can use the formula, which is this. Okay, you use the formula. Future value annuity is annuity, okay, 1 plus k power of n minus 1 divided by k. Okay, this is the formula. Or you can use the table. Okay, or you can use the table. How are you going to use the table? You look at the future value interest factor annuity table. And don't look at the future value interest factor. Look at the future value interest factor annuity table. FVIFA. FVIFA. Then look at the interest rate 5%. Okay, and then N3.